Okay, people, welcome to chemistry. So, first things first, let's just kind of talk about what's going on in this class. So, it's a science class, right? So, what is science? Science is just studying the world around us, everything. So, the textbook definition here is it's the investigation of natural phenomena. So, just trying to figure out how things work. Lots of times you hear technology kind of thrown in the mixer, like what exactly is technology? Well, it's the application of science. So when you figure out how things work, you're able to use that information to do cool things. So chances are you're watching this video on a laptop or a tablet or even a phone, which is crazy because think of it. You're holding this little phone and it's like getting this video out of the air like magic. But it's not magic, it's science, right? And technology, it's the application of that science. And where does chemistry fit into all of this? Well, chemistry, it's the study of matter and how that matter can change. So matter and its transformations. There's a couple questions in your book. Take a peek at those. I'm going to skip in the video here just to keep this a little bit shorter. So since chemistry is the study of matter and how it changes, let's just talk about what matter is first, like what is matter, and then we'll get into the changes later. So matter is anything that has mass and volume. So basically mass is like, it would have weight if you put it in a gravitational field. Volume just takes up space. So anything that has mass and takes up space is something we call matter. So the light shining on you from the sun would not be considered matter. The sound you're hearing, right, that's not matter. It's a ripple in the matter, but those things aren't matter. But matter is like stuff. So I like calling it just stuff. So your stuff can be either pure substance or a mixture. And a pure substance is either an element or a compound. So some of you guys might know that water, right, the stuff you drink, H2O, that's the chemical formula for water. It's a compound. A compound is something that's made up of more than one element. So water is a compound, but we can break water down into hydrogen and oxygen. And those things cannot be easily broken into simpler substances. So we call those things elements. Now let's go to mixtures. A mixture. What is a mixture? Well, it's just what it sounds like. It's a mixture of two or more things. It could be either homogeneous or heterogeneous. This has to do with when you're looking at it. So with your eyes, does it look completely uniform or does it look different? If I take salt and pepper and put them together, right, that's a heterogeneous mixture because you can see clearly there's different parts to it. But if I were to take salt and sugar, especially if they were like the same size little granules, and mix those all together, that'd be really hard to tell those things apart. That'd be a homogeneous mixture. Or if I took some salt and put it into water and stirred that up, homogeneous, right? You can't see the difference there. So here's this little picture. We have atoms of an element. This could be something like helium. Molecules of an element. This could be something like oxygen or nitrogen. And molecules of a compound. This could be something like boron trifluoride. And then here's just a big old mix of things. So if you get right down to the atomic scale, like everything's going to look different, but our eyes aren't that good. So we go to just what can you see? Like if you're trying to figure out if it's a homogeneous or heterogeneous mix. So just use your eyes. If it looks all the same, it's homogeneous. All right, here's a little flow chart. If you want to take a peek at or try to figure out like, is something a heterogeneous mix? Is it a homogeneous mix? Is it a compound? Is it an element? All right, if it looks like a mixture, it's a heterogeneous mixture, right? So if it looks like a mixture of things and you can tell, it's not uniform throughout, that's the easiest one to spot. Now it gets a little funkier over here. If it's all homogeneous, if it all looks like the same thing, the question you have to ask yourself is, does it have a variable composition? All right, so a pure substance will not have a variable composition. If I were to give you, everybody in this class, a glass of water and some salt and say, make me a saltwater solution, do you think everybody would use the same exact ratio of salt to water? No, they definitely would not. So there'd be a variable composition. But if I were to look at the water itself and test the water, every single time I do that, it's going to be 88.8% oxygen. It's going to be 11.2% hydrogen. Never fails. It is always that same exact percent by mass, right? It is a pure substance. All right, but can I separate that water into its building blocks, right? So I know it's made of oxygen and hydrogen. Can I break that up into oxygen and hydrogen? Yes, I can. So I know that water is a compound, right? But if you can't break the stuff up, it's going to be an element. Another kind of a cheat way to spot an element if you're doing a problem is, we haven't talked about the periodic table yet, but there's this thing called the periodic table. And if it's on the periodic table, it's an element. because that table is just a giant list of all of our elements that we know of. All right, so that's matter. Let's go into some physical properties of matter. Physical properties. What the heck is a physical property? So a physical property is something that you can determine without changing the substance. So the color. If I look over there and go, oh, that thing's green. All right, I didn't have to change the stuff to figure out that particular property. But what if I want to figure out if it's flammable? I go put a match to the stuff and then I burn it up, right? Then I figure out, okay, yeah, it reacts with oxygen. That's a combustion reaction. So the problem is now I've changed my stuff, right? So it reacted and it formed something new. So when you're determining chemical properties, it's talking about how it reacts. And when it's reacting, it's becoming something else, right? So it's no longer what it was, it's something new. These properties can be either intensive or extensive. An intensive property, that means it's independent of how much stuff you have. So my favorite example of an intensive property would be color. So if I have 1 drop of yellow paint, or if I have 1 gallon of yellow paint, and I said, what color is it? It's yellow. All right, so it doesn't matter how much stuff you have, but something like length or mass, that depends on how much stuff you have. Those would be extensive. So extensive depends on how much you have. Intensive is independent of how much stuff you have. All right, let's get into the states. The states we're going to care about in this class are going to be solid, liquid, and gas. All right, and here's kind of a funky picture and something for you guys to think about. Water is a really weird substance. We commonly see water in its 3 states of matter on a daily basis. Like you're exhaling right now, you're breathing. All right, so there's water vapor all around you. You probably had a drink or washed your hands or did something like that, so you saw some liquid water, and I bet that maybe at some point today you might use an ice cube. All right, so think of how many other things like that you'll see in the 3 states of matter. All right, so like I said, the states that we're going to care about are solid, liquid, and gas. Those are not the only states. There's Bose, Einstein, and condensates. There's plasma, but I'm just going to skip those because I don't want this video to be ridiculously long. You should know the different physical changes. So when a liquid becomes a solid, that's freezing. When solid becomes a liquid, that's melting. When liquid becomes a gas, it's vaporization. Gas becomes a liquid, that's condensation. When a solid goes to gas, that's sublimation. Gas straight to solid is called deposition. So good to know. Chemical changes, when you have a chemical change, so a physical change, you're just changing one of these states. A chemical change, your stuff becomes new stuff. Its physical properties and chemical properties will change on you. So we start off with reactants, and those reactants will form what we call products. So if I have hydrogen and oxygen, right? Hydrogen has its own set of physical and chemical properties. Oxygen has its own set of physical and chemical properties. Those things react, they form water. This has its own set of physical and chemical properties that are totally different from the starting material. So my favorite example of this, really, really good example that I will babble on a little bit here, is sodium and chlorine. So sodium metal, elemental sodium, all right? It's a really reactive metal. You should, like, after this video, go Google elemental sodium in water and look at the images. Like, the stuff explodes when it hits water, all right? It reacts super violently. It produces hydrogen gas and a lot of heat, and that's enough heat to actually ignite the sodium or ignite the hydrogen. So it burns and explodes. So let's say you're a really not wise person and you wanted to like pop a big old chunk of sodium like it was a vitamin, and you put a big swig of water in your mouth and hucked in a chunk of sodium. You'd kind of blow your jaw off your head. It's like, it'd probably kill you. It's really bad, really nasty stuff. Chlorine gas, also nasty, nasty stuff. If you had a bunch of chlorine in the room with you right now, you'd croak, right? Not even like so much chlorine that it's like displacing all the oxygen. Just some chlorine. Chlorine is just toxic and nasty. If you smell it, ugh, burns your nose. Really bad stuff. But sodium and chloride, when they react, they form sodium chloride. Salt, table salt. You need sodium chloride to live. If you do not have sodium chloride in your diet, you will die. This is essential to life. So sodium chloride, the compound, is essential to live. But sodium and chlorine by themselves would kill you. So that's a really cool example of the fact that the physical and chemical properties of the reactants have nothing to do with the physical and chemical properties of the product they produce. All right, last thing here. Talk about the scientific method. Going to cruise through this really quick. It's a systematic way of approaching a problem and studying it and trying to figure out what's going on. So the first thing you do is collect some facts. You make an observation. So actually not on this little picture here, but you're going to make an observation. Something's going to strike you like that's weird or interesting, and you're going to start collecting some facts. You're going to summarize all those facts, and those are your scientific laws. There's no explanation in a law as to what's going on. It's just summarizes the behavior, period. So it doesn't try to explain anything. The next step, that's what's hiding in here, is the hypothesis. That's where you do try to explain what's going on. But what's really important with the hypothesis is it has to be testable. If you cannot test it, you can't run this thing through the whole scientific method, right? So you need to be able to test it. So once this hypothesis is tested by several experiments, it becomes a theory, right? So then this theory can be used to set up a model. And a model it could either be a picture, kind of like this. This is a model of the scientific method. It could be like a ball and stick model showing you the shape of a molecule. It could be an equation. Like all those things would count as a scientific model. Once you have that set, you can then make predictions. So once you kind of like have an idea of what's going on, you can use that to make predictions and see like, yeah, exactly what it says, predict. So predict what's going to happen. And then you collect new data, and then this whole thing just keeps going round and round, and then you go back and refine. And that's how it works. So it's constantly trying to refine and come up with like the best explanation of what we see going around in the world around us. All right. So I'm going to wrap that up and call that good for video number 1. All right, catch you next time.